Hello, this video is going to be on regression analysis. It's going to be a quick introduction into regression analysis, what it is, and how it can be executed in R by using linear model functions. Next week, we will continue our discussions on linear regression analysis. And as a matter of fact, we are going to come back to regression analysis when we talk about regression decision trees and when we talk more about different versions of regression analysis, such as lasso and ridge. We use them mostly on classification problems. But this video is going to be about a quick introduction into regression analysis and what it is and how we can actually use it in R. Okay, so let's get started. As a quick reminder, in these videos, I handpick topics and I talk about them. I either show you a tool or explain complex relationship in these videos that I find difficult to understand, maybe on your own. If I'm not talking about a certain topic listed in your textbook, please go ahead and review the entire section, entire chapter in your textbook. It doesn't really mean that I'm leaving them out. I am actually utilizing my time on some of the complex topics that I handpicked. I reviewed first, and then I found them useful to include in my videos. All right, let's get started. Regression analysis is a very nice tool or methodology that we almost all researchers from all different variety of science fields use to identify relationships between one or many different variables in a certain data set. This could be cross-sectional data where time is not a factor, or time series data where time is a main factor. So what do we have in regression analysis? We are actually having a target variable or a response variable or a dependent variable or a variable that we would like to predict or explain based on other variables. Okay, so I specified three different keywords: dependent variable, response variable, and target variable. They all refer to the same variable. Okay, I might be using them interchangeably, but they all refer to the same variable. So with this dependent variable, we do have some independent variables where we are going to be utilizing them to explain the changes or variation in this dependent variable. And the tool that we use to explain it is called linear regression. So well, actually, linear term is optional. If regression is giving you the fact that there is a nonlinear relationship between your dependent variable and independent variables, then it might be called nonlinear regression, right? So you have to be very careful with the structure of the independent variables versus the dependent variable. Okay, but in the context of this course, we are going to study linear regression variants, okay, especially in this week. So if there is only one dependent variable and one independent variable, then we call this simple regression. If we have more than one independent variables, then we call this multiple regression. So what makes it linear? Well, if your regression is a simple straight line type of function, then it is a simple linear regression. And you can have multiple linear regression, but this time it is not going to be a line. Those are going to be hyperplanes, right? When you have more than one independent variables. So independent variables can also be called as explanatory or predictor variables. But most of the time, people like to use, or researchers would like to use, dependent variable for the one that you are trying to predict, and independent variables are going to be the ones that you're going to use to predict the changes in the dependent variable. Okay, so the first stage of exploring the relationship between different variables is actually just plotting the scatter plots. Let's assume that we do have just two variables, and in the first stage into exploring the relationship between them, we already learned that in module 1 is to explore scatter plots and try to visually assess the relationship between them. Let's get started with our data set. So our first data set is a pharmaceutical data company's data set. It's called Pharmex. Let's open it up, and we do see three different columns. So we do have multiple different regions in our data set. And what else we have? We do have the promote column. And based on these promotions, the number of sales that we made in these regions. Okay, that's what we have. And we do have 50 different regions. So our objective is um, to try to explain the changes in sales. So sales would be our dependent variable in this scenario by using the promote columns. Okay, so promote column is going to be our independent variable, and we're going to use the promote column to explain the changes in sales. So what kind of relationship we can put together is going to be the key. So the first stage into it is to put together a scatter plot. We already learned how to do this kind of charting techniques in module 1 in Excel. Let's try to see how we can do it in R. All right, so I also posted this R file. It's called simple linear regression.r. Please go ahead and open it up, and let's try to import this Pharmex Excel file into this R file first. Okay, as you can see, this global environment section is empty. I haven't imported it yet. So what I will do is I will go from Excel. I'll go to this folder, and then I will click on Pharmex data, open it up. Let me preview it. Yes, everything looks good. And I click import. Now it is imported. I do have my Pharmex data frame here. It has three different columns. It looks good. Let's take a look at the structure of this data. All right, str Pharmex. Okay, let's execute it on my Mac. I hit Command and Enter. Okay, it gives me that I do have three different numerical values. Oh, in regression, so mathematically, you could only run numerical values in your regression, but ours linear model functions is smart to identify your categorical variables. So I'm going to talk about them in the next video, how we can introduce non-numeric categorical variables in R so that R could understand them as categorical variables. But let's move forward. So another thing that we could use to identify the basic statistics of a specific data frame is called the describe function, and that can be found under the psych package, right? So let's run this two lines together. So let's select them all, and then let's hit comment and return. If you're using PC, it should be control and enter. Okay, and this actually first loads the psych package and then call the describe function. And I could also see some certain statistics, basic descriptive statistics of this Pharmex data. Okay, so let's plot it. So what I'm going to do here is we are going to put the sales column on y-axis and the promote column on x-axis. Okay, the very basic plotting function in R is called plot. Okay, and then what it does is it is going to actually have the x-axis. It's going to have two variables, x and y, and then whatever you put in here as a formula is going to identify the relationship. So if you hover on the function plot, it's going to say, give me x and y. This is just one way of putting variables into the plot function. Another way is to plug in the formula. Well, how do you plug in the formula? I'm going to tell R that I would like to represent sales in terms of promote column of the Pharmex data frame. Okay, so if you execute this command, it is going to show up like this. So it is actually trying to, well, it actually put the sales on the y-axis and promote on the x-axis, and each data point is corresponding to a simple row in our data set. So we do see a positive correlation between promote and sales columns, right? That is something that we can conclude. Or we can just definitely take a look at the estimation of the correlation coefficient between promote and sales, right? And we already learned how to do it in R. It is the pairs.panels function. And then we only would like to look at the correlation between the second and third column of the Farmex data frame, and this is how we represent it, right? So the right side of the comma, if you remember, stands for the columns. The left side of the column, comma in the square bracket represents the rows. So we want to see all rows of the second and third column in this correlation analysis graph. So if you execute this, it will bring out this nice pairs.panels picture. And then you can see the scatter plot here as well, right? You could see that the correlation coefficient is positive. It is greater than 0.5. It is actually an indication that there is a strong positive correlation between promotes and sales. And these are specific histograms of promotes and sales data. So promote data looks like a bell curve. It looks like a good fit to normal probability distribution. Sales, not that much, but it is not really violating the bell curve shape at all. Okay, so correlation and scatter plot is a good first indication of assessing the relationship between two variables. But what about regression, right? What about regression? How we can build it up? So we to be able to put together a linear regression, we use the LM function. Okay, LM function represents linear model. Okay, LM stands for linear model. What we are going to do is we are going to fit a linear model to this data set, and it's going to be our regression model. So before we move forward, let's call the help menu for LM. So LM belongs to the stats package, and it is basically fitting the linear models. It gives you all bunch of explanations of what you can put in this LM function. And at the end, you can see the use cases of this LM function. But I'm going to start explaining the simple linear regression version of this LM model. Okay, so as always, we do create objects or variables in R, and then we'd like to keep them so that we can refer back to them later on after we make operations in R, right? So in this case, I'm going to call this my first simple linear regression LM1. All right, so you can change this name. You can name it after you. You can name it after your child. You can name it your best friend, right? But it is important to remember what you name it. All right. So what I will do, I always do this. So I call it LM1. And whenever I create the next regression line, I call it LM2, LM3, LM4. So it helps me backtrack. If I see an error, it helps me backtrack to my most recent working regression variable. Okay, and then I called LM function. I opened the parentheses, so I entered my formula here. It is very important to import this data frame first. Otherwise, this R is going to give me a problem saying that, okay, what is sales and what is promote? Well, I already know that sales and promotes, those are the column names on this data frame called Farmex. And I do put a comma here. And then I say that, hey, linear model function, go ahead and have Farmex data frame as your data and try to predict the changes in sales by using the promote column. It is very important to understand what this tilde does. Tilde is the name of the symbol. It is the Greek letter. And what it does is it basically tells R that this is the formula that I am trying to fit by using linear regression. So on the left-hand side of the tilde, you put the dependent variable. And on the right side of this tilde, you put the independent variable or variables. When we are running multiple linear regression, we are going to expand this formula. But when we do expand this, we are going to expand this on the right side of this tilde. Okay, so let's run this line, execute it. It created my linear model objects. It actually fit my linear regression model. And let's call the summary statistics of linear regression model 1 that I just created, and let's execute it. If you look at the console, you see the results. Okay. So R is understanding that my linear model function is correct, right? So it is basically calling this. And these are some statistics about the errors that the linear function creates. I will skip these for now. And then the most important table is this table. All right. So basically, it tells me that I do have an intercept, right? So my sales is equal to this intercept 25.1264 plus 0.7623 times the promote. Whatever that promote value is going to give me my sales data. So I look at the standard error of the mean of these intercept and promote, right? And I look at the t-value, t-statistics of these. But these two are not really that much, making any value to the discussion. I am going to look at these estimates, all right, the coefficients of the intercept and the promote variable here, because I'm going to be using them in my regression equation and these p-values. All right, so the p-values of intercept and promote are very low. Well, they are less than 0.05, means that those are statistically significant. So those are statistically significant in explaining the changes in the sales data. If you have multiple linear regression and you have, for example, let's talk about just a simple linear regression case. If this promote had a p-value that is greater than 0.05, then I would conclude that promote is not really statistically sufficient to be used to explain the changes in the sales column of this data set. So these star values would represent these legends here. So basically, this 3-star meaning that you can practically assume that this number is 0, right? That's what it means. And then 1-star means that 1-star means that, so it is very close to 0.01. That's what it means, these stars. So if it is greater than 0.05, then you would see these kind of legends here, right? Another important number to take a look at here is the fact that I got this p-value. It's not a surprise that this p-value is same as this p-value here. This is the p-value of the test. The test is significant, okay? The test is basically the regression model. And then another important number to pay attention to here is the R-square value. My R-square value is a number between 0 and 1. And if it is closer to 1, it means that my linear regression model is very close to being accurate, well, 100% accuracy, and predicting the changes in the sales data. If it is 0, for example, it means that my linear model is not really performing that well in explaining the changes in sales. In this case, this 45.29% or 0.4529 is somewhere in between, right? This basically, the interpretation of this number is the following. So the promote column in my data frame, okay, explains 45% of the changes or the variations in the sales data. Well, think about it. Your sales data 45% of the changes or the variation in the sales data can be explained by only one column, one observation. What about the rest? 55% can be explained by using other information. And I don't know them yet because I don't have those information available to me. If I had more information, such as number of people worked on it, the dollar value of the advertisements that you ran in those regions, you would have incorporated those into your equation. And then hopefully this R-square value would have jumped from 45%. Well, by itself, promote column explains 45% of the changes in the sales data. Okay, that's what it means. All right, so this is your formula. Well, based on these coefficients of the estimate, right, 25.1264, your sales is basically can be approximated by this function. And how do we use it? Well, we use the predict function to predict the future sales values. Once you have new data, promote data available coming from different regions, like in this case, you, for example, let's assume that 5 other regions reported their promote numbers, and let's try to estimate the future sales values for those regions, all right? The key thing here is to create a new data frame and keep your values in the new data frame so that you could actually call the predict function to predict them all, right? So how do we create a new data frame? We type data.frame. It will create a new data frame. And what will this do is it is going to assign the promote name to this vector, okay? So it is highly important that you stick to the same name, because the data frame that I just imported here, Farmex, has this promote name, right, in the independent variable column, and it is explaining the sales changes. So it is important to give it the same name. And in the predict function, we are going to call the linear model that we just created here, okay, LM1. That's where the name becomes very important. So this is to refer to this regression model we created here by using the Farmex data, right? And now we are asking this linear model 1 to make new predictions, because now we are keeping this new data set in a new data frame, and we are feeding this predict function with the new data and the regression model we just trained, okay? And we keep this in a different data set. I'm not sure whether this is going to be a data frame or variable, but let's run this. So let's first keep this, run this line 32, where we keep the new observation. So this is a data frame and has a promote column. And these are the 5 different numbers here, right? It doesn't have sales column, which is not really that much important because the sales are going to be predicted. Okay, predicted sales, let's call this line 34. Let's execute it. And predicted sales is going to be created here. I think it's not created as data frame, so it's just a variable that has 5 different observations. And let's see what those future sales are. I just executed line 36 to see the values of these numbers. Okay, so if your promote number from a region is 98, then your expected sales is 99.83. Is this accurate? And just to do a sanity check, we can just copy this function, okay? And then we can come over here and try to run this. So replace this promote with 98, okay? And just run this piece in the code, right? And then you see that it is actually executing this regression line correctly, and it is giving you the same number. All right, so this is how you can put together your first linear regression model in R, and how you can make predictions by using R's predict function. As a summary, you use LM function and the formula and the data, right? Store this linear model in a variable, any variable name that you use. I used LM1. You can retrieve the results by summary typing the name of this linear model inside it. And then you can have the new data by using the same independent variable in a data frame and using the predict function to predict the future sales. Okay, we are going to continue this discussion, but this will be the end of this video.